All right. Well, welcome back, everybody. We are blessed again to have Fred Williams talking, and he's the co-host of Real Science Radio. I encourage you to go into their rsr.org. They do a telethon, or they just make donations there. They need money to stay on the air, and they're doing a great job. They also have they have a store there at rsr.org. And again, there's no foundation behind them. There's no mega church. It's just them and the Lord and us, the ones who want to get the truth out there. And so again, let's vote with our money and let's be an encouragement to the people who put so much time in here. And with that, I can't wait. Oh yeah, we've got this book that the 20 reasons to question plate tectonics. You guys can download this on the link if you go into hydroplate.org, and you guys are getting just a wealth of information. So feel free to donate. And I'm very excited to see what Fred has to say about this. Take her away, Fred.
Okay, thanks a lot, Brian. So this talk is on problems with plate tectonics, and so it's going to go through a book written by Ellis Hughes on 20 reasons to question plate tectonics. So I do want to mention I'm not an expert here. I'm not a geologist. Just view me as a reporter of this book. And I'm not going to do the book justice. I highly recommend getting the book. You can get it at rsr.org/store, and I've got a copy right here. Very well written book. I don't know if that background, there we go. You can kind of see it. It's very well written and put together, very concise, very well researched, and good references, which is always something I like. So let's go ahead and dive into this. So I want to start with this quote from Christian Smoot, and he wrote this in a book in 2004. And this guy, he's a scientist who worked for the U.S. Navy, and he went on 68 cruises around the globe mapping the ocean floor. It was all classified work. And he was a huge believer. He claims he was a staunch believer in plate tectonics until he got to observe firsthand what's underneath the ocean floors. And he became a staunch opponent to it because then he realized it just wasn't right. Here's one quote that's mentioned, I believe, on the back cover of the book. For the working hypothesis to function, it must explain every geological phenomenon in every instance. Otherwise, we are left in netherworld of ad hoc explanations for every aberration, and plate tectonics is the ultimate repository for ad hocism. So let's go ahead. I did want to mention again, Brian mentioned that this is our website for Real Science Radio. You can get there at rsr.org. And again, we started a YouTube channel, which has been a lot of fun. Everything's on video. With video, you get to see more graphics, video clips, whatever, that just makes it a little bit easier to follow. But, you know, we still love our audio audience, our radio audience, and the podcast and Spotify and all those. That's still our largest audience. But just know you always have the opportunity to go watch the same thing you listen to on video on YouTube. And we also have a channel on Rumble. Okay. So plate tectonics, there's 7 major and 8 minor plates. And it's funny that Smoot kind of tongue-in-cheek said, you know, every day there's a new plate they invent. So here's a picture, and I believe this is from Wikipedia, of the major plates. Okay, so a quick rundown of plate tectonics. They rely on a lot of things, but their primary evidences kind of fall under this category: seafloor spreading, plate subduction, and rising magma. Wikipedia opens by stating plate tectonics is a scientific theory that Earth's lithosphere comprises a number of large tectonic plates which have been slowly moving since about 3.4 billion years ago. So let's not make any mistake about what plate tectonics is. It's an old Earth paradigm. It fits very well with their attack on Genesis when you get to the actual spiritual component behind it. The wisdom of the world is foolishness to God. Okay, so seafloor spreading. The claim goes that rocks are older on the continents. So as you go from the mid-ocean ridge where new ocean crust is being formed, rocks increasingly get older till you get to the continental crust. Tom Davies said this in 1998, "Indeed, we have yet to find rocks older than 200 million years in the deep oceans. These observations led to a rapid acceptance of the plate tectonics hypothesis." So according to Smoot in his book, this quote by Davis that Davis made was a lie. He said that deep sea drilling never penetrated ocean rock, at least away from the ridge. So I don't know about that. But anyways, this quote in itself is highly questionable. but we're going to continue on. I like how the book had a brief history on how plate tectonics became the paradigm. And you can even read about it with Smoot stuff about how he got tired of trying to publish anything because they'd reject it if it challenged the theory. So this quote's from the book. By the late 1970s, groupthink had taken over, and the editorial boards of most professional journals were pressured by their financial sponsors not to publish papers that argued against plate tectonics. We all know that the same happens with creation or against evolution. Grant money was denied to anyone suspected of not being on board with the PT program. So again, we've seen that before. So I'm going to start going through the reasons listed in this book. Again, 20 reasons to question plate tectonics. Very well put together. I can't go through all the reasons because I don't have enough time. So me as really more of a layperson when it comes to geology, I picked the ones that were most compelling to me. So first of all, reason number one, there are too many miles of divergent boundaries. So what are divergent boundaries? That's where seafloor is being created. So just think of the mid-Atlantic ridge that hopefully you've seen plenty of images of that if you watched some of the videos today and yesterday and the day before on the hydroplate theory. Convergent boundaries are where these seafloors that are spreading eventually hit resistance, say a continent, and they subduct underneath the continent. That's convergent boundaries. So if you look at this image here, you look at the subduction movement along West South Africa and notice much more divergence from the mid-Atlantic ridge here. And then you've got subduction at the Atlantic plate. North American plate is a huge problem that, quote from a geophysicist, is still being investigated. And Wiki says the only subduction zone is along the Caribbean plate here. So, right here, these are sliding next to each other, and then you have subduction here. So, again, there's a huge discrepancy between divergent and convergent zones. So that's the first reason. So now let's, and by the way, they try to solve those problems with reason one by creating minor plates to try to get around it. So reason number two, there is no adequate explanation of how subduction starts. And so a lot of these slides are going to come from both Walt Brown's book and Brian Nichols' presentation on the internet on YouTube, which I highly recommend. I'm sure others have recommended it. I believe one of his videos already has over 100,000 viewers, which is fantastic. We need to get that up to millions, but that's still a really good start. The presentations are extremely well done. If you really want to learn about the hydroplate theory in the most concise way that I've seen, and also get into the details, please check out Brian Nichols' YouTube channel. Well, lots of good stuff there. So anyways, he's got this diagram, and it's a method called static analysis. So as a mechanical engineer, him and Walt Brown Brown was also got his PhD in mechanical engineering. When you actually look at the physics behind the claim that plates can subduct underneath another plate of granite, the math does not work. It doesn't even come close. If you look at the force of one direction against the plate coming down, against the force of the plate moving down, measurements are done and some assumptions are made here, but a lot of these are favorable to subduction. You just can't get the forces you need for this guy to subduct. It's remarkable, the discrepancy. And this was mentioned I believe in Brian's talk. Lately, the convection theory has been much debated as modern techniques based on 3D seismic tomography still fail to recognize these predicted large-scale convection cells. And I have a talk earlier, if you missed it, we got to be careful of how we reference seismic tomography because there's a lot of assumptions built into those and problems. Okay. CPT, plate subduction, this is from Christian Smoot. Deep earthquakes do not define a descending slab. In fact, do not even occur in most places along the trenches. Therefore, subduction does not occur. Plate tectonics does not work. Reason number four. Okay, the Pacific Ocean doesn't have enough distinct spreading centers, even though it covers a large section of the globe. So if you look at all the convergent boundaries, and then this is supposed to be the East Pacific Rise, which looks a lot different, by the way, than the Mid-Atlantic Ocean, the Mid-Atlantic Ocean Ridge, the MOR. This is a lot flatter. But anyways, this is where you have to get your seafloor spreading in the Pacific. And so they knew of this problem, the geophysicists and the geologists. And so here's a quote that was mentioned in the book. There is only one option. The East Pacific Rise must be the primary spreading center for the Pacific Ocean, even though it was far from the center. The theorists trusted that as time went on, more spreading sites would be found. But until then, this was it. So they needed more spreading sites. So they theorized, they made a prediction that there would be this area called the Darwin Rise. And it actually turned out to be a failed prediction of plate tectonics. It was hoped for to be somewhere inside this circle, and they did not find it. The guy who proposed it, H.W. Minard, he proposed it again to address the lack of divergent zones. Well, Christian Smoot, who's not a creationist by any means, he comes along and he was able to publish this. They researched that area, and there's no evidence of a ridge. And he said, based on this information, if the Darwin Rise ever existed, it had to have done so elsewhere. It's a failed prediction. So, you know, when I read this in the book, I thought ChatGPT can have some really good uses. And so it's interesting what ChatGPT did here. So I asked ChatGPT this: is the East Pacific Rise the only divergent zone in the Pacific? And it said no. It lists as the first one the Mid-Pacific Ridge. I'm like, wow, I hadn't heard of that. And it says this is a network of mid-ocean ridges and divergent boundaries that extend throughout the central and eastern Pacific Ocean. I'm like, wow, this is interesting. And then I did some more Googling. I didn't find anything. So then I thought, well, I'm going to ask ChatGPT this question a little differently, because a lot of times you get different answers based on how you ask the question. So here's what I asked next. Does the Mid-Pacific Ridge really exist? And ChatGPT says, I apologize for any confusion. It appears there may have been a misunderstanding in my previous response as of my last knowledge update in September 2021. He uses that excuse a lot, by the way. I only go up to September 2021. There is no widely recognized geological feature known as the Mid-Pacific Ridge in the Pacific Ocean. Thank you. The term Mid-Pacific Ridge is not commonly used in geology. Instead, the primary mid-ocean ridge system is the East Pacific Rise. It's still pretty much all they got. So reason number 5. If subduction has happened, we should find a huge volume of sediments that have been scraped off as the plate subducted. Instead, we find shallow, relatively undisturbed sediments. So here's a picture of alleged plate subduction going down here. So you'd think as it's scraping along the continental crust, you're going to build up sediments. So this reason is stating, well, you know what? We're not finding this sediment like you'd expect. So we're going to take a look at, here's a drawing of an alleged plate subducting, and you got these seamounts that are apparently going to help, like bulldozers, push the sediment down to help explain this problem. But here's what the author of the book notes. Is it reasonable to think that a cone-shaped object would be able to act like a bulldozer? And they said, you know, imagine pushing an upside-down ice cream cone through wet sand. Wouldn't the sediments slide around the cones? I mean, that's just common sense. Wouldn't the lumpy seamounts act like brakes and slow down the subducting plate? Good point. Would a pile of sediments really be able to lift a 10 to 20 kilometer thick continental plate made of granite? Very, we've already seen on previous slide that's physically it's not possible. So here's what a scientist wrote in 1970 before they really clamped down on opposition to plate tectonics. He said this, and he became an opponent of plate tectonics. He said, given the rate of motion of 3 centimeters per year over 100 million years and an average sediment thickness of 200 meters, the thickness of sediments piled up in a 50-kilometer wide trench should reach 10 kilometers high. Nowhere do we find those deformations in trench sediments which should, under such circumstances, arise. On the contrary, sediments occur undisturbed on the floor of trenches. So evidence you'd expect is missing. And then reason number 7, you can watch my talk on modeling that I gave just before this one. And we go through things like seismic tomography. Well, this book, the author lists seismic tomography has not shown unambiguous images of subducted plates. I provide examples of where it's really a lot of it's just I'm sorry, it's fiction. It's an illusion portrayed as evidence. And one of the quotes I mentioned in the talk is, when you had 20 independent geophysicists analyze seismic data from an area near the Barents Sea, there was considerable variation in interpretation. And then a recent study from 2022 of 5 seismic models on the Chinese mainland, the researchers found that there were large discrepancies existing between the models. And this image here, by the way, was from 1997. So that's before they've even improved the technology. I like what this candid admission, the Canadian Journal of Sciences, or Earth Sciences. Some end users put more confidence in attractive images in a way similar to customers' reaction to an advertising campaign. Plate tectonics is often sold by phony images that are just not, there's no way this thing is accurate. Maybe it perhaps shows something, but it's technology that is not super reliable. If you want to get more details, again, please watch my prior talk on that. Reason number 8 is many-off zones do not prove the existence of diving plates. In fact, the more data that comes in, the more enigmatic they become. So the dots on this graph, they're the epicenters of earthquakes under the Crustal Trench, and this is an area north of Japan. The earthquakes get deeper, farther away from the trench. The trench, by the way, is marked by this star right here. Does the graph show a subducting plate? No, according to the author, and you can just look at this, it shows the epicenters of earthquakes, presumably along a fault plane that slips frequently. Interpreting this as a subducting slab is an inference, and it's not an observation. It's an assumption, an inference. And again, I refer back to Christian Smoot about deep earthquakes do not define a descending slab. I'm not going to quote that again, but the point remains. Reason number 9, the arc and cusp pattern around the ring of fire and along trench zones creates an impossible geometry for plate subduction. Now, reason number 9 for me, again, as someone who's not a geologist and just from an engineering perspective, this is my favorite argument against plate tectonics. I think it's really solid and just anybody can understand it. Brian Nickel does a fantastic demonstration of this. And so here's the demonstration that simulates a straight line subduction scenario, as in the diagrams you'll often see, like in Britannica and elsewhere, of these nice subducting plates. So this is what, but the demonstration is going to simulate that. Here's the perfect world scenario of subduction. However, we know that if you look at around the globe and where they claim subduction is occurring, here's what it's a real world scenario of subduction. Okay. So now if we look at this map, you see where there's subduction allegedly occurring, there should be wrinkles, just like we saw in the prior image. Do we see these when we look at actual data? No, we do not see that at all. Why are they not there? This is basic mechanical engineering. And then the tensile region should tear the plate material. Now, if you watch Brian Nickel's videos, he gives a lot more details and the mechanical engineering equations behind this and all the forces under consideration. It should tear the plate material based on this arc and cusp pattern. We have an arc and then a cusp. And guess what? Here's where you have your arc and your cusp pattern. And do we see these tears? Are they there? They should be there if plate tectonics is true. But guess what? They're not there. They're missing. So I love this argument, and go to Brian Nickel's videos and get more details, but it's just fantastic. It's pretty powerful evidence that plate subduction is not occurring. It just violates mechanical engineering. There seems to be a disconnect between mechanical engineering and geologists. Okay, reason number 11, and this is pretty easy to understand just for anybody, the uneven topography of the lithosphere-asthenosphere interface makes it impossible for continental plates to move. So here's a continental crust, lithosphere, and then you got the asthenosphere beneath it. So just look at how uneven the topography is, and you can get maps and ideas of this all over the place. How is these plates going to move? You have just this uneven surface. It boggles the imagination to wonder how that could happen. So here's a quote from Meyerhoff, and this is a guy who has a different theory for tectonics. He opposes plate tectonics. So he raised this objection. Today, geologists and geophysicists tend to treat pieces of the Earth's crust like a room of furniture, objects that can be pushed around at will into whatever configuration is required to satisfy a particular model. It sounds like when they were grinding down Lucy's bones to make it fit their theory. Unfortunately, the Earth's crust is not so easily manipulated if one is faithful to physical laws. So please, let's become faithful to physical laws. There's so many problems, and this is another one. He states that the lithosphere is like a massive 100-kilometer deep interlocking mosaic of uneven rock, which makes plate motion extremely unlikely. Okay, reason number 12. The rocks on the mid-Atlantic ridge should be the youngest rocks in the Atlantic, yet there's much data that challenges this claim. So if you remember arguments for plate tectonics, the rocks are supposed to be young here, and then they get older as you go out. So this is from 1972 study. The rocks here, according to plate tectonic theory, should be less than 10 million radiometric years. However, the rocks give a radiometric ages up to 2 billion years. Here at St. Peter and St. Paul rocks, right in the mid-Atlantic ridge, the MOR, mid-oceanic ridge or the mid-Atlantic ridge, specifically right here. So seafloor spreading, I added this from a slide that when I had talked about plate tectonics, I found this in a study from I don't have the name of the study listed here, but anyways, plate tectonic understanding of seafloor, and I'm quoting the article, plate tectonic understanding of seafloor spreading maintains that Jurassic recent crust below the oceans is basaltic apart from local occurrences of extended continental crust adjacent to continents. However, abundant samples of continental material, some as old as Precambrian, Paleozoic, have been cored and dredged from deep oceans. And these are from compilations from these guys. And the conclusion that they had in their paper was paleontologists should assert priority of their data over plate tectonic model. So they agree that the evidence doesn't support their theory. Reason 13 is another one that's easy to see. This was Bollard's fit that was originally used to support plate tectonics. And this is his diagram right here. And here's the major problem. Central America is missing, for one. Africa was shrunk by 40% to get this to fit. The continents had to be rotated, and some were clockwise, other counterclockwise. Wow, that's amazing what seafloor spreading can do. How did seafloor spreading manage to not only move the continents apart, but rotate them? Great question. That was reason 13. And as you've probably heard in many talks on the hydroplate theory, hopefully, what is really the better fit is the mid-Atlantic ridge and the breaking up of the fountains of the Great Deep here, and then the sliding of plates this way and that way, and then you see the crumpling of mountains, etc. So that's more of a better fit, not some jigsaw fit that Bullard had proposed. And by the way, he used a numerical model, a computer model, oh boy, to support his work. So we've seen that before. And again, I'd refer back to my modeling presentation to see the problems with that. Okay. Reason 14, fracture zones along the ridges are said to show the direction of seafloor spreading in the past. As we map more of the ocean floor, we find many fracture zones and fault lines that challenge this hypothesis. So this map here was drawn by bathymetry expert Christian Smoot, who we referred to before, using the data, but he and his team members had gathered over many decades of scientific cruises. He said he went on 68. The red lines were added by the author that make clear where problems are, they're problematic. So these aren't great evidences. There's a lot of contradictory evidence to this whole claim about fracture zones, showing the direction of seafloor spreading. So here's from Christian Smoot, quoting him, fracture zones distorted in National Geographic maps in a way that supports PT, rather than showing the direction of seafloor spreading, leave nothing more than a pattern of at least 4 different directions on the ocean floor as they intersect in a random fashion. Okay, reason 17, this is a fun one. So magma is a compressible fluid and sinks when below 200 kilometers. This means that mantle convection and mantle plumes are impossible. So we're going to take a look at this image from the Encyclopedia Britannica. It's fairly representative, and we'll see the problems here. So here's a plate subducting. Nice little pretty graphic. But is it real? And look at the rising magma. And oh, by the way, look at that number. We'll get to that. So we're piling on again. So CPT, rising magma. So what's the problem here? So density affects buoyancy. Kevin Lee has a great presentation on this, demonstrates this whole concept. I can give a brief analogy of, imagine at some point, maybe you played with rubber duckies in the bathtub and you like to push them under the water and you let go of the rubber ducky and it plops up. And that's because the pressure of the water is greater than the duck, and the pressure of the water increases with depth. So if you're in a huge pool, a large deep pool, and you took that rubber ducky down the pool, at some point you're going to let go of that rubber ducky, and it isn't going to go up, it's going to go down, because the pressure of the water became greater, and the density of the rubber ducky became so compressed that the pressure of the water around it rules the day, and the thing sinks. And again, Kevin Lee has a great demonstration of this. So density is directly proportional to pressure, and as pressure increases, density increases. So the fact that they found that magma was compressible, that's a serious problem for the plate tectonics theorists and their whole thing about plumes and whatnot. So I'm not going to read all these quotes. You'll have them here in the presentation, but this is the studies that show that magma is compressible. Here's a demonstration. I believe this comes from Brian Nichols' presentation. So crossover depth at 220 miles, magma is going to go up. Okay? These are laws of physics. Magma below the crossover depth is going to sink into the mantle, into the core. Okay, it's going to go down. So back to the Encyclopedia Britannica image. Look at that number. Oops, it's not possible. So this whole diagram is invalidated by science, by real science, by physics. We've got a show where we talk about the Hawaii hotspots. I recommend, if you want to learn more about it there, we've got a lot of information refuting this whole idea that the Hawaiian hotspots are, rising magma. And the book, again, 20 Reasons, they have a good section on the problems with hotspots and that whole hypothesis. It just doesn't work. Get the book, please. They got a great explanation, but you can also go to rsr.org/hotspot. Okay, reason number 18. And that's when we've dug these really deep holes. So the one in the deepest holes ever drilled in the Kola Peninsula in Germany, and they showed some plate tectonics predictions were wrong. We covered these in the modeling talk. The big takeaways from this was the interpretations of seismic data can be very wrong, and this is from the author of the book. It is incredibly difficult to drill down to the mantle, and it is therefore unlikely this will become a readily available source of data. And by the way, it costs between $200,000 and $800,000 per day to drill. And you can look that up online. It's very expensive and very difficult. And it's the only way that you can get any kind of subtle validation of these models. And even when you do have borehole data, it didn't match their seismic models. So why are we putting so much trust and faith in seismic models? And I get into a slightly more detail in my talk earlier today, or you can go and read my modeling paper. Okay, moving on. Ellis Hughes wrote this: the German KTP borehole taught geologists the same lesson that the Kola borehole did. Seismic studies give us very limited information about what is deep underground. Plate tectonic theory has not proven useful in predicting what we'll find when we dig deep into the ground. Okay, this is from Russian geologists on the Kola project. The traditional idea that geological data obtained from the surface can be directly correlated with geological materials in the deep crust must be re-examined. We agree. The Kola borehole revealed how far from truth scientific theories can roam. How true? We agree. Okay, reason number 20. This is probably covered the most in this book with the most details, and I'll do my best to go through it. So even though magnetic anomalies helped plate tectonic theory to gain acceptance, there are many problems surrounding them. So let's first talk about the magnetic stripe explanation that was supporting plate tectonic theory believed at the time. So if you look at the spreading centers, for example, the mid-Atlantic ridge, the crust they noticed is separated into parallel bands of rock by successive waves of emergent data. So as lava's coming out, over time, the Earth's geomagnetic field undergoes a reversal, allegedly, and the change in polarity is thus recorded in the magma. And it contributes to this alternating pattern of magnetic striping on the seafloor. So they saw this pattern, and they're thinking, wow, this is recorded periods of time of magnetic reversals over time. And this is kind of confirming that these dates are changing as you get from the ridge. So this particular image here is an artist drawing from 1966, but it's interesting. They picked this area here to make their hypothesis of magnetic striping matching, spreading seafloors. But look at this. Does that work so well? No, not so much. So this looks like selective data to me. So let's look at this map from the USGS 2009. So the red on this image is normal polarity, and the blue is reverse polarity. So up here is Iceland, and you can see, where they see, oh, look, this looks like we see spreading. But as you look at this, there's all kinds of problems. I mean, where do you see the same effect in other areas that are supposed to be spreading? And then over here in this region near Alaska, you see this V-shaped pattern. And I believe the author notes that they'll create plates to kind of try to explain that kind of data. So, and I just personally looking at this as common sense wise, you see the pattern here and then you don't see it for a while, then you see it here. Now, of course, they'll just have a just so story and say, well, maybe there's a lot of magnetic reversals of here and here, here and here. Well, then why don't you see the same thing here? To me, you have to create a lot of just so stories to defend this argument. So this is another case where I went to Google or Chat GPT. And because I've heard this argument where they claim that magnetic reversals correspond to rock age increase from the mid-oceanic ridge. And they said, oh, yes, magnetic reversals do correspond to an increase in age of the rocks as you move away from the mid-ocean ridges. And notice down here, correlation with age. Geologists can determine the age of these magnetic stripes by dating the rocks and sediments in the ocean floor. Now, if you're paying attention, that sounds a lot like circular reasoning to me. So there isn't a corresponding age. It only corresponds because they're using the data rocks to date the magnetic reversal age. And when I asked ChatGPT, isn't this circular reasoning? It says, well, it can appear that way, but there's so many other things that validate, their independent dating mechanisms and blah, blah, this and that. Sorry to the, to the open eye, this is circular reasoning. And then there's evidence of rapid reversals. For example, there's this dike in Arizona right here. And so you've got this concept that lava flowed in a crack. And so this had to have occurred rapidly. Well, guess what? They found reversals, alleged reversals. I'm not sure if did the Earth really reverse magnetic polarity? Maybe, I don't know. That seems kind of far-fetched, but let's run with it. This shows evidence of magnetic reversal. So research on the dike formation in Linzhou Basin, China showed normal and reverse polarity. And then Dr. Russ Humphreys had done work on this in the past, and they had noted that Steen's Mountain seemed to support his theory of rapid reversal during the flood, which I don't have a problem with that, from a hydroplate theory point of view either. There could have been some really nasty stuff going on during the flood. There's obviously the Earth was going under a ton of turmoil, but secular scientists had reported on this, and then apparently some of the co-authors of this paper tried to backtrack in later years because of pressure, but it's not what the evidence showed. The evidence showed the rapidity and large amplitude of geomagnetic variation that we infer from the remnants, directions, and flow B51, even when regarded as impulse during a polarity transition, truly strains the imagination. They saw all kinds of evidence of rapid reversal in Steen's Mountain. So that flies against their whole magnetic reversal argument as far as evidence of, it happens every so many million years and it fits the seafloor spreading. Well, now here you've got evidence of rapid reversal. So the paper goes on to list some the book. It goes through some alternative theories, and I'm not going to go into details here on those. You can, if you want to know about them, you can certainly, get the book. We highly encourage that. So you have global wrench tectonics, surge tectonics. I think we briefly mentioned one of the authors for that in this presentation. Shock dynamics, geology. And then the book does cover the basic aspects of the hydroplate theory, which, of course, many of us watching this at this conference believe by far is the most viable theory to explain what we see around the globe, and not just around the globe, but out in space. And I'm looking forward to Dr. Rob Brown's presentation on trans-Neptunian objects, and Doug McBurney will also be getting into comets and asteroids. All really fascinating and great stuff. I believe Kevin Lee has a talk coming up on earthquakes. So there's some really good alternative theories. I'm not so sure about these three, but you've got the hydroplate theory. I know that, geologist Phil Budd, who's a friend of mine, he has a theory called collapse tectonics. So there's other ideas out there. Phil Budd certainly doesn't buy into the catastrophic plate theory. And, he points out that there's so many ways you can mess with numerics and parameters. So the book, again, covers these alternative theories. So here's the verdict. Contrary to popular opinion among earth scientists, the purveyors of plate tectonics are the present-day snake oil salesmen. This comes from Christian Smoot, who, again, for years was a proponent for plate tectonics, firmly believed in it until he saw firsthand. And who better than firsthand the guy who works for the U.S. Navy, and he's mapping the ocean floors in classified information for work with defending the nation from Russian submarines and whatnot. So he said this. I'll continue. Plate tectonics is fraught with misinformation and misconceptions. Mid-ocean ridge spreading does not occur universally, especially in Iceland and the North Pacific Basin. Deep earthquakes do not define a descending slab, in fact, do not even occur in most places along the trenches. Therefore, subduction does not occur. Continental drift is a figment of overly active imaginations. Couldn't agree more. And again, this guy, he spent 32 years mapping the ocean floor. And looking at my notes here, he actually claimed 67 cruises. And he was responsible to help declassify some of the data for the U.S. Navy. And again, at one point he was a devoutly believed in plate tectonics theory. So when you actually look at the data, it doesn't work. There's so many problems, and to me, problems that outright falsify plate tectonics. The physics don't work, and observation doesn't fit the data. Okay, so this last bit here, this is a slide from Bob Minyard when he gave his talk on predictions of the hydroplate theory and then his arguments against catastrophic plate tectonics. He has a 3-part video, which is excellent, on the hydroplate theory and the flood. And part 3 of that video goes through a lot of the problems with catastrophic plate tectonics. So when he gave that presentation, he's like, please, we got to rest in peace. We should get rid of this. It's not valid. And you can get that video at rsar.org/store and just look for the hydroplate theory video, the 3-part video from Bob Minyard. I think it's a great presentation. The first part of the video is a lot of times going through the theology, the biblical evidence for the hydroplate theory, which far and away has the most biblical support. And then he covers, of course, the evidences for it, and then he gets into the problems with catastrophic plate tectonics. All right. Well, I believe that's it for me. And I appreciate everybody's time in listening to this talk. I again highly encourage the book. I wasn't able to go through all the 20 reasons. I went through the ones that were, I guess, sunk in the most for me and that I thought I could fit into 40 minutes. And so, again, highly encourage you to get this book. It's excellent.
Indeed. Yeah. You can get it at rsr.org. And I encourage you to get a whole bunch of other stuff. You can do all your Christmas shopping. And a lot of this is online, but what if the internet goes down? Just, yeah, because it's good to have it because they could censor a website or two. So again, get this video, this rsr.org. And if you're interested in that smoots, that the guy who mapped the oceans, Bob Enyart actually interviewed Ellen McHenry 3 or 4 years ago. And the title of that, if you go into rsr.org, it's called Smoot versus Plate Tectonics. Smoots versus Plate Tectonics, and very, very eye-opening. And thank you so much, Fred. That was a wealth of information. We'll dive into the questions here. How best should we argue against the fact that the plates are moving at a few inches every year, like your finger?
I can take a first stab at that. And I know we've got, I believe, Brian Nickel on the call too, which is a really top-notch resource. But, one of the arguments is you have GPS data that shows plates moving, and we don't dispute that. We see a very slight movement. For example, the North American plate, a lot of the GPS movement is towards the Pacific, which you would expect as there's still a little bit of settling. And when I heard that argument for hydroplate theory, I was at a conference, an ICR conference, where Tim Clary was in the middle of talking about catastrophic plate tectonics. And I'm busy on my phone, and this is true. Coincidence, but I'm looking for evidence that GPS is slowing, that the plates are slowing, because that would fit the hydroplate's claim that this motion's going towards the Pacific, but it's settling. So settling to me as an engineer also means, okay, it's slowing. Well, for some reason, I believe they think that maybe it does support their theory too, because while I'm searching for this on Google, Dr. Clary goes, oh, by the way, we have evidence that plate movements are slowing.
Wow.
Oh, great. Okay, thank you. I can, maybe I'll talk to you afterwards and I'll get those citations.
Wow.
And then another thing really quick, when I was debating a creationist on this, who supports CPT, of course, I cited that in Iceland, they don't use the type of precise techniques that we developed at Trimble for measuring movement. And he said, well, they've got these GPS studies of these stationary things moving. And so he provided me the data, and I looked at the data. I'm like, well, what about this one here? It's going in the wrong direction. Wow. And he goes, well, that's an area of high tectonic activity. So to me, you have a convenient way to explain problems. That to me is raises an eyebrow at the very least. Again, I'm not an expert, but I can look at data. He provided another example of an island in the south. Where was that one? That was in, I think, near the Caribbean. And I showed him the same thing. He showed me data that allegedly showed plate movements, and then I showed him contradictory data from the same GPS data points that were being fed into this program. And I didn't get a reply to that one when I rebutted that one, and it could be because he was busy, because I totally understand that, but okay.
Yeah, Dwayne says, excellent answer. Thanks. And where can I find substantial proof that the mantle is not fluid/liquid? Seismic P and S waves show that this, but I need to find the data. What would you recommend?
So he asked for substantial proof that the mantle is not liquid or fluid. And unfortunately, that's out of our realm. We don't have a reliable way of doing that. So I can't recommend anywhere other than dying and asking Jesus. But don't die on purpose. We get to ask Christ that when I don't think will we ever get the technology as successful as, say, to MRI or CAT scan the earth in a way that we can more trust and rely on that data. The problem is we can't validate it. There's just no way. We see how expensive it is just to validate a pinprick into the earth with,
right.
With our drilling that we've done.
Right. Mark says we need to create our own chat GPT. Yeah. Okay. Is there a clarification about magnetic reversals in general? Walt Brown infers less and more magnetic strength due to cooling in ridges and valleys. Setterfield seems to agree that magnetic reversals are a real thing. not using ocean stripping as a reason. Any views on that, magnetic reversals?
Yeah, and I'll let Ellen or Brian speak to that, because I know Ellen did some in her research on this when she was reaching out to a friend of mine who's a geophysicist. It is hard to pin down really what's going on. Walt Brown has a good explanation for it, but I believe Ellen, and I'm sorry I'm speaking for you, but you could mention you had difficult time establishing Walt Brown's claims on this.
Yeah, I did a little bit of research for some other project. I just happened to come across needing information about magnetic striping, so I looked into it. Yeah, and you provided me with some experts. And after several months of thinking of researching, I came to the conclusion, yeah, they are real. It's a very real phenomenon. And but I also came to the conclusion that hydroplate theory is going to turn out to be the only way to explain them. We just need we need more research on that. But I think hydroplate theory is going to provide the answer. But I was convinced they're real.
There's actually there's a paper by I think he's an electrical engineer named Rod Nance, and I think Walt even might reference him in his book. And Rod had contacted me a few years back, and he had a paper on reversals and some of the issues with those claims about reversals, just from an electrical engineering standpoint, and the whole concept of a geodynamo. And I think that's a pretty well written paper that explains some of the, I think, very real problems of like, how does the dynamo go to zero and actually then reverse? Because if it's gonna flip, then it has to go through a 0 point node, and if it does that, it can't really revive itself after that. So, and this is coming from me, I'm not super technical in that, but he pointed out some real problems with the idea that say the outer core, the liquid outer core, is what's providing the magnetism. He thinks it's from the inner core, and anyway, there's some problems with convection being the cause of the geodynamo, because everything is all connected, and in a electric motor, when you're producing that current, it's insulated. There's insulation between the convection cells, if you will, in the form of the wrapped wires and whatnot that are causing the magnetism and the convection. And in the earth, you do not have insulation, and so there's no way for the motor to actually work the way that they claim it does. So his name is Rod, R-O-D, and it's Nance, N-A-N-C-E.
Okay. Yeah, and just one other thing, the person that I talked to Rod. That was one of the people I talked to. Another person who's an expert in the field said that the only way to explain his idea was that, yeah, as things exist now, it's impossible. But the only way you could get that would be if you started out with not a liquid core, and then you had a quickly enlarging. You went from nothing to what we have now. That's where you would get the reversals, this process or whatever. And so it didn't happen at first. And then during the short period when the liquid outer core was growing, it would have happened. And now it doesn't happen anymore. That was his idea. That was a short period of time when the liquid outer core was growing. So that's his connection to hydroplate.
Then that person asks, how are ocean floors polarity of rocks actually measured? Do they drop something right down onto the surface, or is it floating on top? Do you guys know? Have any idea?
Both.
Both? Okay. All right. And then Dwayne says, I hope there was fair. On your answer is fair. I hope there was data that showed a failing theory due to the fact that one of those do not translate through fluid, either the P or the S. Or am I off base, is what he asked.
Yeah, so primary waves are the ones that go through, will make it through the earth, and S waves won't. They're better for constraining more subsurface areas that are closer to the surface. But again, even geophysicists admit that the deeper you go, the more difficult and less accurate the waves are. So you have to make in my view, that they'll say educated guesses. I'd say when you're looking at the core, you're making closer to guesses than educated guess. I mean, I guess you have some knowledge of the velocity of a wave because they slow down during through things that are hot, things that are cold. Solid rock, they're going to travel faster, but that's what you're dealing with mostly is wave velocity. You're dealing with the velocities of wave and trying to analyze and come up, okay, what does this thing under here look like? And the deeper you go into the earth, the harder it is, and the more speculative it becomes. So again, that's not an answer I think we'll ever know conclusively until we meet Jesus. But I could be wrong. Maybe they'll come up with some ingenious way to have a better way to do it.